Assalamu alaikum dear students. I welcome you to the lesson 18. We are going through the chapter number 4, Sensation, Attention and Perception. And the topic which we are going to read today is Depth and Space Perception. Okay, what is depth perception? Actually, depth or space perception is the cognition of stimulus with reference to width, length and direction. In depth perception, actually, it is the visual ability to perceive the world in three dimensions. Depth perception is the visual ability of our mind to view the world around us in three dimensions. Although our eyes are able to see in two dimensions, but the visual to perceive or to interpret the world or the things or the stimulus around us in three dimensions is known as depth perception. When we know stimulus in terms of length, width, thickness, and depth, this is called space perception. When we are able to look around the world in three dimensions, look the things with regard to their width, length, direction, depth, or thickness. When we say that, for example, when we say that a road is so long, it means that there is much space between its initial and the final points. Okay? Width is also known in terms of space between both sides. The same rule applies to thickness. The more widely spaced one end is from the other, the thicker the object will be. Depth is also measured from one point to the other. Okay? The more space there is between 2 points, the greater the depth will be. Since the elements of space are predominantly involved in length, width, thickness, and depth, all are included in space perception. Space perception is of much importance to our lives as well. We identify distant and near objects through space perception, and we take measures to avoid accidents and lead a comfortable life. This is due to our ability of the mind to see the two-dimensional world into three dimensions so that to avoid accidents or to lead a comfortable life. Though we draw upon all sensations in depth and space perception, auditory and visual sensations are more important in this regard. Our eyes perceive space and depth with the help of different environmental clues. One or both eyes can be involved. Okay. Similarly, our ears detect auditory cues which help in estimating the distance and direction of sound. So, auditory cues can be detected with one or both ears. So, let's discuss the visual and auditory cues in detail. Space perception with the help of vision. How we perceive depth or how we perceive the thickness, width, length, or depth of any object around us. For example, if we see a book lying on a table, this is our visual and mental capability to view the book in regard to its width, its length, its thickness. This is depth perception, perceiving the width, the thickness, the height, or the depth of the book. So, let's discuss space perception with the help of vision. Perceptual organization naturally takes place in the form of figure and ground during depth and space perception. The effect created by figure and ground also forms the basis of depth. Whenever we see an object, we see that object in regard to its environment or in regard to its ground. Actually, the thing which we are focusing is the figure. So, in depth perception, we are creating the image in regard to figure and ground. There are actually two types of cues which are involved in depth perception: monocular cues and binocular cues. We are going to read the monocular cues and binocular cues one by one in detail. Monocular cues, okay. If we see with one eye, following cues in the external environment prove helpful. Number one, interposition. If an object is fully clear in the visual field and has blocked some other object, we estimate that the partially blocked object is located at a distance and the object in front of us is relatively near. This is interposition. For example, in the given figure, the circle is partially blocked by a square, by a triangle, and a square is partially blocked by this circle. For this reason, this triangle looks a bit nearer and this circle looks looks to be the most distant object. So this monocular cue interposition says that whenever an object is blocked, it seems to be distant from us. And this object, which is in front of in front of the other stimulus, or it is at the front of the visual field, it will be regarded, it will be seen as a nearer one. Okay. Second monocular cue is relative movement or relative motion. The way objects move across our visual field gives us space perception. The faster the objects move, the nearer they seem to be. While traveling in a train, car, or bus, we feel that the near objects are moving fast in the opposite direction. When we are traveling in a car, we see that the nearby objects are moving backward or moving in opposite direction and are very fast. And a little bit remote or far objects are moving at a bit slower speed in the opposite direction, and the very remote objects are moving at a very slow speed in the same direction. So the direction and speed of their movement gives us the perception of space. Okay? This is a monocular cue known as relative movement. When we are moving in a car, although we are stationary, we are not moving, the car is moving, and the near objects are moving fast in the opposite direction, and the far off objects move very slowly. This is a monocular cue, and due to this monocular cue, we are able to receive perceptions smoothly and to interpret them. Otherwise, our brain will be jumbled with the haphazard sensations around us. Another monocular cue is the relative size. If two stimuli are of same size, the stimulus that appears bigger will be nearer than the stimulus that appears smaller. In this given figure, the nearby balls look bigger than the distant balls because of relative size. Although the balls are of same size, but the ball which is close to us seems to be bigger as compared to the other balls. So relative size is another monocular cue, and due to this monocular cue we are able to adjust. Otherwise, our mind will not be able to comprehend that why we are seeing some objects of different sizes, although in actual they are of same size. Why our vision is not perceiving them, why we are not perceiving them of equal size? It is just because of the distance. Okay, so the next monocular cue is the relative height. If the similar objects are located beside one another, the lower object will seem closer than the other objects. For example, in the given figure, the lower trees look bigger and the higher trees look smaller. The closer figure seems to be bigger as compared to the distant figure. Also, for this reason, the higher figure produces space perception. And because of this, we are able to perceive this depth and space. Another monocular cue is relative clearness. The object that is clearer than other objects in the visual field will look nearer, whereas the distant objects will be vague. The objects which are close to us, which are close in the visual field, will be will look nearer, will be clearer and nearer as compared to the far off objects. As we can see in this picture, in this example, these stones are near to us. They seem to be clear as compared to the clouds and the water behind it. So relative clearness says that the object is clear if it is near to us, if it is near to the visual field, or if it is near in the visual field. Okay. Another monocular cue is light and shadow. Light and shadow also produce depth perception. Light shows all the details of the stimulus clearly, whereas stimulus looks vague and blurred in shadow. Light makes space perception easier. Because of this light, we can see the details of the object, and because of these details, we can clearly assess what the object is. The objects look vague, unclear, and blur in the shadow. So, light gives us proper vision. Another monocular cue is accommodation. When our eyes detect a distant or nearer object, it adjusts itself to the location of stimulus. The lens of the eye contracts in case of distant stimulus. When an object is far from us, far in the visual field, the eyes will contract and thicken if the stimulus is nearer. Or we can say that if the stimulus is close to our eyes, or the stimulus is close in the visual field, the eyes will widen, the eyes will be dilated, the pupils will be dilated. This ability of the lens is known as accommodation and it facilitates in space perception. Okay. Accommodation is a monocular cue in which our eyes adjust to see the near objects or the far off objects by contracting or relaxing the eye, by contracting or dilating the eye. Another monocular cue is the linear perspective. As two similar parallel objects grow smaller, the distance is perceived to be greater. For example, the railway tracks, when near, seem to be spaced apart, but as it moves further to a single point in the distance, because of linear perspective, the parallel lines of the railway track or of the trees along the roadside seem to converge at a point in the distance, like this. The horizon and the earth appear to meet because of this linear perspective. We see that here the horizon and the earth seem to meet. This is a monocular cue known as linear perspective. When two similar parallel objects grow smaller, the distance is perceived to be greater. Another monocular cue is a texture gradient. The details and the constituent elements of the texture of a closed stimulus look very clear and distant. As the distance between the stimulus and the observer increases, the texture of the stimulus appears very fine and even. Okay? For example, as we can see in this picture, the near or the close field seem to be rough, or the texture seems to be rough, and further in the visual field we can see that it has become plain and clearer. So as the distance increases, the texture of the stimulus seems to be fine and seems to be even. This is a monocular cue known as texture gradient. So these were the monocular cues. Now we are going to read the binocular cues. The binocular cues actually facilitate depth perception, and there are two major types, the retinal disparity and convergence. What is retinal disparity? Okay. Space perception depends upon our visual system. The distance between the lenses of both eye is about 6.3 centimeters. And for this reason, the retinal images of both eyes are slightly different. The lenses of the eye are at about 6.3 centimeter at a distance of 6.3 centimeters. And because of this distance, the retinal image of both the eyes is slightly different. We see differently from both the eyes. This difference is known as retinal disparity. Okay, this minute or this small difference is known as retinal disparity. As you can see in this figure, when you see it with your left eye, you will see the left part more clear. And the object seen with the right eye, the right part is more clear. And this little bit of difference is known as retinal disparity. We know that the visual fields of our eyes are different. When we see with both eyes, the difference in the visual field is not very noticeable. Okay? But when we look at the same stimulus with both eyes by turn, one by one, this difference is very clear. That is to say, when we see with the right eye, the right side of the visual field is less clear than the left side. Similarly, when the left eye closed, we see the right side of the visual field more clearly than the left side. We can take another example. For example, stretch your right arm fully and point your finger at something in the room so that your finger is exactly in front of that thing. Or your finger is exactly at the front of your right eye. Just as just as we can see in this figure, pointing towards the figure, pointing towards this house. Close your left eye first. Keep your finger at the same position and open the left eye, closing the right eye. The stimulus will shift, jumping away from its position. Okay, reopening and reclosing of your eyes will bring out the importance of visual fields. This important cue facilitates depth perception. This retinal disparity facilitates depth perception. Is it clear? Okay. Another binocular cue is convergence. Our eyes have muscular elasticity. When we look fixedly at a distant stimulus or a closed object or closed stimulus, eyes adjust accordingly. Similarly, as we have discussed earlier in the monocular cues, the accommodation process in which our eyes dilate or contract while seeing the distant and nearer objects. Similarly, binocular cue is convergence, in which the movement of pupils produces variation in space perception. For example, hold a pencil at some distance in front of any person beside you, in front of the eye of the person beside you. Ask him to look at it fixedly. Slowly draw the pencil nearer to the eyes and now observe the pupil of that person. And you will see them turning towards the nose, turning inward. This movement of pupil produces variation in space perception. And this process is called convergence. But this perception is not produced when a very long distance is involved. Okay? You will be moving a pencil from a small distance, then this convergence will be produced. So these were the monocular and binocular cues of space perception with the help of vision. Now we are going to read this space perception with the help of hearing. Space perception can also be held through sound. The sensory organ for the sound is obviously the ears. The ears, on detecting a sound, can decide how distant, deep, and high the sound is, and from where the sound is coming. Ears perceive space with cues of two types: monaural cues and binaural cues. So let's discuss the space perception with the help of monaural cues. Being able to perceive space with one ear is far better than being deaf, actually. One ear can accurately perceive the direction and distance of sounds when the ear faces the sound origin. If the ear faces the opposite to the sound origin, space perception becomes difficult. When we are able to know from where the sound is coming, we are able to perceive it well as compared to when we don't know the origin. So, monaural cues refer to the space perception with one ear. Okay? These cues are of two types: distance from sound origin and direction of sound. Distance from sound origin. Accurate information about sound origin has a very important role in space perception. This information can be gathered on the basis of the characteristics of sound that include the loudness and the wavelength. These waves produce perception of the sound origin when they reach the ear at a specific frequency. Both ears together can detect sound more clearly than one ear. Okay? The reason is that sounds come from all directions, which helps in uh, estimating the sound. When loud sounds reach the ear, the sound origin is presumed to be nearer, while in case of low sound and soft sounds, we assume that the sound origin is far away from us. When we are listening to something, the intensity of the sound waves keeps on changing. This continuous change also affects our space perception. So, accurate information about the sound origin has a very important role in space perception. From where the sound is coming, what is the source of sound? When when complex sound waves reach us traveling through the air, their complexity comes to an end. For example, the organ being played in the distance sounds soft. In case it is near, the sound is felt to be loud and complex. These complexities of sound are produced by timbre, the quality of sound. The quality of sound, known as timbre, facilitates the discovery of sound origin. Okay. The more complex a sound is, the nearer it will be to the listener. Many elements are involved in space perception. The sound that feels like filling the whole space is perceived to be coming from near and engulfs other sounds. The other monaural cue is the direction of sound. Normally, we perceive space only through sound without drawing upon any other clue. This perception is possible even with one ear. Sound waves scatter all around in the air from their origin, we know that. Actually, when the sound waves strike the eardrum, the ear has no perception of the origin and direction of sound. For example, if a sound comes from two different sources or two different origins that are more or less equidistant but have different directions, the perceiver with one ear will not be able to distinguish the directions between the sound from both directions, will produce similar effects. However, two ears can detect the origin of sound. The perception of the direction is not possible with one ear. We are able to perceive the direction of sound with two ears. So, these two were the monaural cues, the distance from the sound origin and the direction of sound. Now we are going to read space perception with the help of binaural cues. Normally, both ears can accurately detect the direction of sound. Binaural cues refer to the cues that can detect the sound origin with the help of both ears. In monaural cues, only one ear was involved. Space perception with one ear is the monaural cue, and space perception with the help of two ears is the binaural cue. So, we will be discussing space perception with the help of binaural cues in terms of time difference, intensity difference, head movements, and different other cues. Time difference. The ear facing the sound origin detects the sound a bit earlier than the other ear. This is called time difference. The ear which is facing the sound, which is facing the stimulus, the sound stimulus, will be receiving the waves earlier as compared to the other ear. There will be a slight difference, and this difference is the time difference. Experiments have also proved that if one ear detects a sound even by 1/30th of second earlier than the other ear, the direction and space of the sound can be perceived. Okay? Intensity difference. The ear facing the sound origin will perceive the sound to be louder, while the other ear will find it a bit lower or softer. As it is obviously, the ear which is facing the sound origin will be having direct sound waves, and those will be much louder as compared to the sound waves which reach the other ear. This is referred to as intensity difference. Okay. Similarly, if the sound waves are made to come from above or below, or they fluctuate between front and back, the individual with his eyes closed can guess, but not accurately perceive the direction of sound. Beside this, head movements and other cues also facilitate space perception. Okay, let's discuss the head movements. In order to guess the accurate direction of sound, we shift our head. This enables us to judge the sound with both ears and to find the direction. Often, when we hear a sound, in order to guess the accurate direction and space, we shift our head, we move our head. And due to this movement, we are able to locate the sound source and the direction of the sound actually. The head movements also enable us to perceive whether the sound is coming from left, right, from back, or from front. The various angles of the head movement and the difference of sound samples produce different effects on both ears. It facilitates accurate perception of direction and space as well. The other binaural cues, when visual and auditory stimulus occur at the same time, we can perceive whether those stimulus come from the same object in space, object in place or not. Many other cues also occupy a significant role in perceiving the direction and space of the sound. For example, the lip movement of a person tell us whether the voice is coming from his mouth, though the voice reaches our ears slightly later than the lip movement. Okay, that is why if the dubbing in a film or drama is faulty, the viewer at once detects that the voice and the lip movement are not coordinated. Apart from this, mental set and learning also have a role in detecting the distance and the direction of sound. Experience also matters. Although visual and auditory stimulus reach to us maybe at the same time, but sometimes we are unable to coordinate. Sometimes the movements or the stimulus are not coordinated, and because of our experience, because of our learning factor, we come to know the difference. So, this was today's topic. We learned about depth and space perception. Depth perception is actually viewing the world in three dimensions. Although our eyes have the capability of seeing the or viewing the world around us in two dimensions, why we are able to perceive the world in three dimensions? Because of the monocular and binocular cues. We have read space perception with the help of monocular, binocular, monaural, and binaural cues. Similarly, we read in detail the space perception with the help of vision and hearing. Hope the topic is clear. It's an interesting topic. We will be coming with the next lecture. Till then, take care and Allah Hafiz.